said, I look forward to see every single person in AI innovation. Okay, so people online are just asking how classes have been so far. We're familiar with this, we know this. So please, let's begin to sign the attendance. Um, let's sign the attendance so that we can, and we'll see one of the important reasons we should sign the attendance today. I'm going to show us the record so far so that we can see where we stand and things that we need to. Right, nice. Ido, I'm very glad to hear that you now understand machine learning AI and can deploy a system. Beautiful. I'm glad to read all this feedback, and this is absolutely amazing. Now, I want to throw a challenge to us before we actually close the class. And one of that challenge is the same thing following from yesterday. That I'm reading this amazing comment and it's really nice. And it always hurts me when every time, and honestly, think about it, especially this cohort, because we had to close registration for this cohort sometime like 2 weeks ago when we're already way to the cohort, somebody joined, it won't be too efficient. But a new cohort is starting next week, right? It's the same thing. So I don't want to see your face again. Let me see, let me see. I don't want to see your face. It's the same thing, like you want to come, okay, come, you want to come. But really it's the same thing. But I want us to reach out to other people that you know that need this. So I want us to share on our social media when we see it, when we see the designs. I will make sure to share in the classroom or via email. Share with people that need it. Let your friends that you know also need this get it. That's why it's good to share your story, share your learning experience. Imagine if you've been posting every week after the class that learns this, that learns this. Somebody will be like, oh, I need this thing too. How can I join? So because the vision here is, and that's why we do what we do, to make sure that everybody everywhere that needs this knowledge actually has free access to it. And that's why we do what we do. So please, I'm going to be reminding us towards the end of the session as well. Okay, so please go do all to sign the attendance, and you can use the QR code or you can use the link that is on the screen. And a quick reminder that whenever you're filling the attendance, make sure you use the same email you registered with. It's really important, as well as for your quizzes and all that. Okay, all right. So the link to the attendance, oh, it's not dropped on the chat yet. I'm sure it's going to be dropped shortly. Okay, so that's the big announcement really. Like I said already, we have a new cohort of AI every day that's kicking off next week, and it's going to happen every Tuesday and every Wednesday next week. From next week, so that's for 4 weeks. There'll be 2 sessions every week: Tuesday, Wednesday, Tuesday, Wednesday. So I look forward to seeing you. All right. Yes. So AI innovation actually starts 25th of April. Yeah. The link. Can we share the link on the chat for AI innovation? Okay. So on AI innovation, you can start getting registered. There will be AI innovation classes holding here. There are about 6 courses for AI innovation, because AI innovation is 5 straight days for about 2 months. So there are courses, there's a Saturday course like every Saturday. That is 5 straight days. So it's running as well. So you can come in. Yeah, there's a Saturday cohort. But Saturday cohort is every Saturday, so 5 Saturdays, but 5 days for their cohort. So once they share the link, I'll also share on the classroom. You can get access to that. Okay. So I'm going to review. Okay. Yes. So that's why I said there are cohorts. There's a Saturday cohort, right? Special Saturday cohort for people who can't make it on the weekdays. So that runs 5 Saturdays. And then others are just Monday to Friday, 5 days straight. Okay. So what is AI Innovation all about? Alright, so AI Innovation is another learning initiative by Data Scientist Network that teaches machine learning end to end in 5 days and ends with a global hackathon. It's our biggest face-to-face. Do you remember there's one video we played before the session starts that shows previous AI Innovation? It's our biggest learning event where we have over 3,000 people learning across the country. We've done 30 cities, we've done about 40 cities. Now we're doing 80 cities this year. Where we have our community members all around the country, literally. And this year we're even going outside the country, right? just teaching AI for free in locations. So you want to host somewhere, you want to teach people, you want to give back to your community, you can just pick a community somewhere, gather people, and we'll send you a resource person, we'll send you materials to make that happen. As long as you're ready to host, you're ready to do AI revision with you. It's very that simple. So there's a website. My colleague just dropped the link on the chat now. So you can pick it up there if you are interested. I'll also share it on the classroom after this class. Okay. Now for everyone, and I have said it is compulsory for everyone in this course to participate in AI Vision Hackathon. Even if you're not coming for AI Vision class, what? No, it's not physical. It's going to go for about a month, and then we'll send you the data set and all the details you see. You see, it's going to be like it's a competition. And of course, there are some learning engagement prizes and to further your learning for people that do very well. But for AI Vision, really, it's a chance to show you because you're going to be competing with about 3,000 people across Nigeria. It's a chance to show that I have learned AI. And because when you are getting going for data science interviews and jobs, it's a very good portfolio, your competition portfolio to show that you are really good. As a matter of fact, data science Nigeria as at then our cargo competition for the bootcamp because our bootcamp is for the best AI practitioners, data scientists in Nigeria. So if you are on the top of the leaderboard, you can practically say that you are one of the best data scientists in Nigeria and you are not capping. You're not lying. So it's really important to participate in these things. They help to build your career. They help. We have amazing stories of community members, people like Eniola Olaleye, Bamibali Okoyemi, who have participated and competitions have actually helped them build their profiles. Okay, so it's really, really important. So you'll be seeing a lot of promotion and details on that. If you're an AI Plus member, as a matter of fact, you must have gotten an email, something about AI Vision sometime in the last 1 week, right? So we should also do not check our emails, right? Okay. So really important. So really important. Shama, I see your question. I'm going to answer. Okay. You can also reach out to me, maybe wherever you see me, you can reach out to me online. Okay. But what? No, I'm actually very active online. I'm just incognito. Okay. But I'm very active with all social media platforms. Oh, all right. So for the certification criteria, like I said, we have this slide updates following your feedback and special needs. So, as always, still holding is that all assessments have to be completed with an average of at least 80%. That is, across all the assessments, totally there, your average should be at least 80%. Okay, that shows that you have a mastery of what you're doing. So that when we give you a badge at the end that says that you have completed this and you are now a data analyst, you are a machine learning engineer, right? You can actually now prove it. Breaking the bias, thank you, right? And also at least 6 out of the 8 sessions, live sessions must be attended. Now I understand that people got committed later on. There are people that they did not attend for some sessions, and for that reason, we are having the final test. The final test will be not 10 questions, maybe about 20 to 30 questions, and that test will help to make up maybe you have low attendance or you have low scores previously. If you are able to meet the 80% cut in that test, to make up for any assessment or any other attendance that you might not have. So someone that meets up the requirement, yeah, so someone that meets up the requirements already, you do not need to take the test. But you can also still take the test, right? You can also still take the test. It's still totally cool. You can still take the test just for your learning. So the last test is not compulsory. Okay, it's not compulsory, right? But if you feel inclined, you can still take it for your learning. So for people here, oh, someone is asking me to throw more light on AI innovation. Okay, so I'll just go right again. Please drop the link to AI innovation again. Okay, let me also just open the AI innovation website here so that everyone can I can project that and we can all see it. Okay, okay. All right. So I am going to share my screen so you can see for AI innovation. Alright, so AI innovation is all about free AI classes in every city. It's free AI classes in every city. It's a beginner's introduction to machine learning, and it's going to take place in 80 cities. We're going to have about two experts in each city. So we have 160 experts. We have nine cohorts, and it's going to run 5 days. Okay, and it's just to teach beginner level machine learning end to end physically in all these locations. Okay, it will run from April to July. We're going to learn about machine learning, access to expert tutors, the battery completion for the hackathon participants, and there's, I mean, so many things to learn and all. So you can register as a learner, or you want to teach, you have proficient skills. I don't expect anybody from this class to register as a tutor, but no, hold on. But wait, hold on. But as an assistant tutor, yes. So that means you can register as a tutor, and if you get a location that needs an extra tutor, that you are around there, maybe like the neighbors. For example, doing air vision, yes, someone who can come around. Also, help out in the class when my colleagues help out in the class. I mean, there's some you can debug some codes now too, right? So you can also show them that, and you tell them that I started learning this thing a few months ago. Today, I'm not a machine learning engineer. So you are all welcome, right? And that would be really nice to see you all giving back to the community because it's on a volunteer basis. And also for hosts, we need, because this class must happen somewhere, so we need hosts as well. All right. So that is about. Yeah, okay, that's fine. All right. So back to our class for today. Okay. So as always, wherever you are in the world, connect to the Wi-Fi. You can just do that, and you will have access. So back to where we started when we kicked off that. We've learned a lot, right? And I asked that question at the beginning. It's been 8 amazing sessions. It's been about 16 hours of learning. That is almost like your average Coursera course on this topic, about 16 hours. And there's been also, and for us, it's every day. There are content being shared in Google Classroom that you are going through and all that. So my question for us is, yes, there's a support for remuneration and logistics. Now, for us that we've learned so much, my question to us is, how much of what we've learned have we shared with the world? Like we said yesterday, it's really important that people see what you are learning and see what you are doing. I cannot begin to recount stories of people. Someone just reaches out to them on Twitter. Hey, I saw your post, I saw your article, what you said you learned. We have this for me. Can you speak at a week of beginners who will speak at this event? And it's a career step for everyone to say, because one of the most important things in this space is that you are seen and that your work can be seen as well. So we want to share what you are learning. Okay, so let's share our apps. I don't want to see any Fuminis, what's it now? Fuminis insurance prediction app on Twitter. I will comment that this is my app. You've stolen my app. Okay. Yeah, please, if you have your apps, you can actually put it up now. I think I can also go around and just check. But seriously, let's share. It's one of the best things to share. One of the best ways you learn is to teach. Yes, I do. Yeah. Oh, but you shouldn't use the same link. No, the same link won't work if you close it. It will, like I said, if you are running the server locally, it's running from your runtime. So once you stop that code app, you have to run the code again. Yeah, that's why. No, it's not, like I said, it's running, we've not, so that's like one of the articles we'll be sharing post this last is how to fully deploy, like, want to build something that you can sell, right? And that was actually on the plan is because it's a lot. It's not, there's DevOps involved, there are a lot of things involved, right? So it's most likely going to be another mini course that we'll put together on this learning. It will most likely be online, but we'll see what we can do. Okay. But if you want to run, you want to showcase it. What? Yes. No, the system doesn't have to be on. If it's collab, You have about, I think it's 1 hour or so. I don't know what scholar time is now. Once the scholar closes, but if you're running on digital notebook, your laptop has to be on. Yes, no, because that's not fully. That's like I said, it's a test partner. You cannot share. Okay, as long as I'm able to check this out. But yes, what? Okay, no, you need it in your pool. Okay, oh no, 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 of course you have to. So there are ways you can work around that. Okay, one of the things I was trying to do, there are actual ways you can. That one is even piece of it. The actual ways you can work around that. That's why I said in DevOps, there are so many things involved, right? So, but today's class, thank you so much, Fatima. Glad to hear that. Thank you. Don't worry, learning continues. You don't have to be sad. Thank you, but learning continues, okay? Learning continues. So we need to share what we have learned. So as we go from today, what I really want to be seeing is I want to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're 13 here physically and we are about 47 online. That's our 60. I want to see 60 new posts. I want to hear from, I want the social media team to run to me and say, "Fumi, what's going on? Over 60 people have tagged DSN in the last 30 minutes in their amazing learning experience. What's going on?" And this is amazing. That's what we want to see. That show the world that yes, you are learning and you are moving forward in your career. So please let's share what you are doing. Somebody out there needs what you do. Imagine if I decided that okay, I'm not teaching this class. I'm not facilitating, I'm not doing. I don't want to share my knowledge. I'm not going to have the amazing experiences we have had. Nobody will want. Yes, somebody else might have thought it, but there's the uniqueness that every one of us brings to the table. So it's super important. Alright. So I understand that there is a lot we've done, and just to close this session today, my colleague and I will be running us through everything we have learned in the last 6 sessions. I'm going to take reviews, we're going to answer your questions, and we will be taking really serious reviews. That is, we want to know when you've learned, I'm also like you to ask questions. Okay? So we are open to your questions, we want to hear from you. Alright, are you ready to go? Alright, awesome. So we share what we have learned. Oh, you have a question. Okay, questions are already alright. Now, can you imagine if we were using Django in yesterday's class? So, yes, if you want to build a proper web app, you might want to use Django, right? Django or maybe what's the other one now? Um, but anyway, you can use different, whatever works best for you, right? You can use Flask as well. Yeah, Flask. So you can use, but I mean, I might have to Django, but anyway, you can use anyone that works well for you. Yeah, yeah. And you can, so you can build it off of Django itself. I think it was, but yes, yes, it's a framework, yes. But it will just have each of these things have their own limitations that you just have to consider, right? So that's why I said for proper deployment, we're going to take it. It will most likely be another course, like be another cohort, right? Deploying your own because there is DevOps involved. There's DevOps involved. There are workflows are involved. There are things you need to know that you need to so that we are not just pushing anything out there. Yes, Flash. Thank you, Edwin. You're not just pushing anything out there, but that it's being done properly. Okay? Awesome. Alright. So to start off, who wants to remind us what we defined artificial intelligence as? If you recall, we talked about artificial intelligence, so first class, right? And we said how artificial intelligence is blah blah blah, so a bunch of things. So who wants to remind us? I have very short time to spend with you, so who wants to remind us? Go ahead. Online, I want to see your comments. Beautiful. Absolutely nice, nice. Any Any other attempt? Okay. Yes, no, okay now. Absolutely correct. The ability of the computer machine to mimic human intelligence. Beautiful. That's what you wanted to say? Yeah. Oh, is it off? Fine.
Uh, Artificial intelligence involves giving computers the ability to improve learning.
So generally, like we discussed, artificial intelligence really is the ability of computers to mimic human behavior in terms of things that human beings can do intelligently. Yeah, not just humans, but the idea is now, and that's why we talk about the broad. That's why I say I didn't say machine learning. I said artificial intelligence. Artificial intelligence uses machine learning and other things. But the broad overview when we say artificial intelligence is that we're trying to create. That's why we say the intelligence is artificial. It's artificial that is trying to mimic something, and the idea is that the machine can reason, it can think, it can begin to make decisions, it can talk, it can see, and all these things. Yes, at the background we use machine learning, but they come together to create what we know as artificial intelligence. Okay, so and we said how that artificial intelligence is all around us, and that's just what this collage is depicting. Okay, beautiful. Complete. Yes, nice. That's a nice one. Science and engineering making intelligent machines. Nice. Okay, beautiful. So we said in our Google Assistant, Siri, robots we see around us, your Google Maps, what else? Amazon recommendations, YouTube recommendations, Netflix recommendations, your spam in your email. It's all spam is an example of what type of classification. Oh, I said the answer. Okay. All right. So and we said how that there are many tools and frameworks we use to build artificial intelligence applications. You can see on Jam there to build artificial intelligence applications, but they are not artificial intelligence themselves. There are many tools and frameworks that we use to build this. And we said how that the term was first coined by John McCarthy in 1956 at that conference where he defined AI as the science and engineering of making intelligent machines. And there's the philosophical part of AI, there's the physiological part, there's the engineering part, there's the software part, there's the statistics part. Everybody, depending on who you ask, usually always has their own definition. Because we can begin to get philosophical and say, what's the meaning of intelligence? And go on and on. But depending on who you ask and really what the goal is. And that's why we have other definitions, right? Things about leveraging computers to mimic problem solving and decision making capabilities of human mind. I love that definition by IBM. That is the ability of a computer to, or the ability to, it's just a leveraging, it's a use of computers to mimic the problem solving and decision making capabilities of human beings. So a computer can make a decision on its own, it can reason on its own, right? That's all about it. And we said that it's generally very simple definition, giving machines the ability to mimic human behavior in terms of reasoning, logic, science, speech, etc. There are so many branches of AI. We have expert system speech, NLP, machine language, machine learning, robotics, vision. Computer vision is like a whole field of it. So talking about your image. Someone was asking my image processing yesterday. That's computer vision, right? How we can all your Instagram filters, every filter you've ever seen, filter now, not what's this new one? These ones that are used augmented reality to as now. Those ones are actually they're also filters actually, but they have some embedded of AI in them. Your filters are simply they're non-pi maps. They're just non-pi maps that map on your image and augment certain pixels. And there are ways that these feature maps. Really, if you can we can do small projects where we make our own filters. They're really beautiful things. So don't worry, we have other courses, more advanced courses coming for you, like computer vision for experts, beginners. So we have all those kind of courses coming up that you definitely. How do you what? You, like how would yeah, yeah. So as an AI Plus member, we'll always share with everyone via email. There will always be social media publicity on Twitter and of course on the Telegram group as well. Okay, so AI is already all around us, and so we need to, as people, every day see how we can leverage this to make our lives better. And AI is so popular today. Why? Because we're in the data, there's a data explosion. There's so much data around us, and having so much data means that many of the models, mathematical expressions that we had before to do things like artificial intelligence, today we actually have the data that they can work with. In previous years, that data wasn't available. Also, having so much data now creates the question that okay, there's so much data. Now the people that have computers and they have the knowledge, they begin to think, what can we do with this data? And AI always has now always come to answer that question and be the answer to that question. So, like never before seen, we can see the way this graph from 2010, right, up to 2021, and then just keeps climbing. The volume of data generated, consumed, and copied and stored is just alarming. And even when we talk about every minute of the day, right? This one, when I read it, I look at it, it's amazing to think. And so when I send out emails, I try to think of how many people around the world that's also sending out emails at that time. The amount of data flying around is just amazing. Over 167 TikTok videos I didn't watch every minute of the day. Man, over 148,000 Slack messages every minute. 44 million views on Facebook. What? Instagram, users share 65,000 videos every minute. YouTube, 694 users stream. Okay, every minute of the day is 694,000 hours streamed. It's, it's, it's every minute. That's every minute. So you can imagine how many people on this platform are doing things, and so much data is being generated. So there's a large volume of data, and this is just a build that shows us there's a large volume of data. This large volume of data leads to what we know as big data, and there are about 5 V's we use to describe big data. There's the velocity, that is the speed that the data changes, is a lot. There's size, also volume is very large. There's also, I think there is yes, there's also how it is dispersed. So there are so many things, but the concept is it's when we're talking about, we're not talking about 2 gigabytes, we're not talking about petabytes, we're talking really, really large size of data. Okay? So okay, I'm not even done with this. And then what can we now do with this big data? Like I said, how can we understand it? That's why data science comes in. How can we understand what the data is trying to tell us? I've been doing business for many years. I have so much data. Is there a way I can leverage that data to make more intelligent business decisions? And then we derive insights and patterns of this big data. And then these insights and patterns are the things that we now draw into artificial intelligence. And the cycle just continues. So we talked about machine learning. We said machine learning is a subset of AI. It uses statistical methods to help machines improve their experience. The idea of machine learning is that with every experience, the machine keeps getting better. Every time there's more, and experience is data, right? And every time there's new experience, every time there's new data, the machine just does what? Keeps getting better. It's like you are learning, you're at school or you are reading something. The more you read it, the more you understand, right? So there are patterns that we need to see, and I especially love this the leftmost side, the picture of the man on the machine learning something by reading it. That's not machine learning, and it's learning that involves using statistical methods to help machines to learn the patterns in the data set that help them now with every new data point, with every new experience. The aim is to improve the particular process. The whole idea is just constant improvement. That with every new data point, every new experience, there is improvement. Now, we also talked about how machine learning is different from traditional programming. And the general rule, how they are different generally, is just one thing. What is it? It's how they work. Traditional programming takes your data, a bunch of rules and a program, there's some computation and it produces some results. But as you've done machine learning, what can you say? Machine learning will take your data, it will also take the results. Remember your labels. The labels are the results. And then you now do perform some computation and then produce a program, a model, the bunch of rules. As a matter of fact, in there are some techniques we can use to take our model apart and see the pattern in the data set. If you try to do machine learning with Microsoft Excel before, there's something you can do when you do linear regression. You can pull out the mathematical equation that represents the line of best fit. And if you plug your data into the model, the equation, it will give you your answer. So you can actually do that. I know that something that I do sometimes when I want to look at something, I'll just plot the graph, get the equation of the line of best fit, and then begin to use that line to do some things. So that's I'm giving somebody a tip there to make work very easier. Okay. Now we also talk about deep learning. I say deep learning is all about neural networks, trying to model how the brain works, the neurons in the brain, how there's an inbuilt some computation, some weights and biases, and then there's an output. Many of these come together, interconnect to create neurons and to create layers of dense networks, different kinds of neural networks. But basically, deep learning attempts to mimic the human brain. But of course, it's quite far from matching its capability. Yes, question? Yes. So deep learning was really popularized with image classification because it's just finally we were able to see that there are models that can understand images very well, and that's because deep learning works better for higher dimensional data. When we talk about high dimensional data, we think talk about like images, videos, audio, and even about audio. Do you know that with audio processing can be done with signal processing or graphs and all that, but can also be done with computer vision. So there are spectrograms that we can do with audios, visualize the audios, and then yes, and then use those audios as visualizations as new data for the audio. So I'm telling you, every time you say hello, if you record yourself, your voice maybe with Audible or you know how Audible, what's this thing called? All these audio apps, you know there's a waveform, right? If you've ever done sound, so you know there's a waveform. Say hello 10 times and look at the waveform. Even you yourself, you see that they look the same. If you understand, you see that it looks the same. If you say the same all the time, it will look the same. It will look the same. I've done it before, so I can tell you it looks the same. Because it's the same thing you are saying, and the sound waves are how is the representation of the exact the sound wave that you're saying is the mathematical representation. So imagine if we have that image and you see that it's image equals to heading. Every time you see this image makes sense. Of course, there are many different now. This is an oversimplification, just to explain. But it's just one of the many ways that deep learning helps us to solve many of the problems we have today. If one was using AI to identify text, yes, you can use machine learning or deep learning. But if I talk about text classification, because you really want to use deep learning, I want to use something like a recurrent neural network that takes into account, I'm trying to answer Omani's question, that takes into account previous text. Because if you are doing things like maybe language modeling or topic modeling, where you scan through document and you can say this is what the document is talking about. That means every single line in the document must be related to the previous line. That's the only way we can imagine if you pick one line and you say this is what that line means. That might not be. Imagine a document about this class. Some part of this class has covered, we've talked about Python. I have joked in this class about maybe Wi-Fi. Imagine if you just pick the line that talked about Wi-Fi and you say this document talks about Wi-Fi. Is this class a Wi-Fi class? So we need a model that can actually understand and know how each sentence relates with the previous things. And that's how things like that's how your phone can guess the next word you're about to type on keypad. Because it has learned the patterns that every time you type how usually the next word is should. And that's why like for me, and it's amazing. I use Google Board. I can't find the name of the data increase that was shared. Yeah, so I'm going to address that shortly. Um the like for me, I've noticed when you or if you notice now when you type something, if you use emojis a lot, I use emojis a lot when I chat, and you notice if you type something that your phone will begin to suggest emojis to you. It's amazing because it has just learned your pattern of chatting. So AI is when I tell you that we use AI every day, it's we literally not kidding, and they help to create those kind of experiences that oh wow, it's beautiful. You know, like, these days most time I just type two things and every other thing is already there. Just like easy. So we talked about how AI is imparting human intelligence in human intellect to machines. Using logic decision trees, it includes machine learning. How machine learning is a subset of AI, now uses statistical models, and what happens, it improves with experience. The key word in machine learning is improvement with experience or with more data. And now data science is based on analytical evidence, your structured data, and your various data operations trying to understand underlying patterns. And lastly, we talked about the types of AI. Generally, there are three types of AI: artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. And we said how that when artificial narrow intelligence is just saying the machine can only perform specific tasks, similar or close to the level human being can perform those tasks. So when you talk about a task like um task like and this is generally what we have today. Narrow intelligence is only good at one thing, right? It can only perform this task it was trained to do. So you have something like your Google Translate, it can translate languages, right? But if you put a language it has not been trained on, it will not get it, right? So it is only good at doing one task, or it cannot be used to translate an audio. It can't even take audio. So it's only good at one task. That's why it's narrow. Now, general intelligence on the other hand is more generalized and things like your speech assistants, your personal assistant, your AI assistant, like Google Assistant, Siri, they are more close to general intelligence. They can speak, they can see, right? How many of you do Google what's on my screen? It's really cool. You should try it. I didn't know Google Assistant. It's really fun. It will take a screen, it knows and to tell you, oh, this is what's on the screen. Hey Google, read this out to me. It's really amazing. And you can even tell me a joke. And if you don't like the joke, it will adjust itself to what you like. So it's a kind of generalized intelligence that it can perform intellectual tasks on a human level, but we are still not, I mean, it's still not perfect, but generally it can perform multiple tasks, not just one task. Narrow intelligence is just narrow-minded, it's one task. If you say all the AI we build in the machine learning models, they are narrow, they can only predict um, insurance, they can only predict if it's Titanic. If you take your Titanic model and you put it on insurance model, it will fail catastrophically, right? So, and then the super intelligence, how do you write the attendance online? Yeah, so just fill the attendance form. So the artificial super intelligence is how many of you have seen Terminator or Skynet? All those scary movies where they say AI hates somebody, well, AI is so smart, it outsmart. Yes, that is artificial super intelligence. And that does not exist. It's we are a very long way from that. Look at the AI you are building on your laptop now. Is that the AI that will take over the world? I don't think so. But your model will take over the world in terms of business, right? But taking over the world in terms of be bow to you, right? What? Yes. No, and the thing is, for those kind of things, they will only, for example, there were cases where we had AI models released in times past, and people began to because they know it learns from experience, they began to say bad news to it, and because it learns with every input it takes, the AI began to speak to us too, because people were speaking like that too. A lot of that, I was joking with a friend. Okay, so if you feel like we're going to sort out this attendance and all those issues out shortly. Alright, so super intelligence is the machines that surpass human intellectual capacity. They can predict the future. There's one movie I always like to recommend about it. I don't remember the title actually. It's about an AI that they built that took over one guy's life because the AI was trying to maybe kill him president or something. I don't remember. The AI knew they to tell the guy to call his guy's phone and then just wait, take two steps to the left, or attack that van, do this. And it led him literally through the day. And how was able to predict how to the next thing to do, what will happen. Yeah, but that's artificial super intelligence, and trust me, we are not even close to that. Yeah, the Q6 is the F1 score, yes, Q6 is the F1 score. Alright, so that is the end for um the first part of this class on how far we have gone in terms of general AI and ML. Now, before we go on, I would like to show us something. Right now, I have posted in the classroom the attendance for the class. And it looks something like this: your attendance and your quiz scores. So, quiz 6 was the F1 score thing we did. So, there is that. So I've also tried to color code it that if the attendance is yes, you see a green. If it's a no, you see a red. So you can check it out. It's already on the classroom. Now I'm already seeing some comments that yes, already on the classroom. I'm already seeing some comments that I came, I didn't see my name, this, that. Now, and that's one of the reasons why you must always fill the attendance with your right email address. Do you get it? Your email address is really important. So for people that maybe have those issues, make sure that you yes that so if it's white or it's you see the numbers. So the green ones for the quizzes are above 80, but for quiz 6 it's just above 70 because that's F1 score, and then the other whites are just that. So the idea here is make sure you fill with your email address registered with. Yes, this is not everything. It's a very long and this is your name at all. Alright, so the only names here, the only names here, and this attendance stops yesterday. Today's attendance will be coming and updated. The only names here are the names of people who have completed at least one quiz. So even if you have done a quiz and your name is still not there, that most likely means that the email address you filled with the quiz, maybe it's not the email address you registered with. And we can check and we can confirm after, but I can see after the class and actually check because you're here physically, right? And that's why this is published early. You can check the classroom, the link is there, right? So only people that have at least a quiz submitted, right? Yeah, but remember that you must always read with the email address you registered with. Yes, that's really important. So you see that if you have submitted the email address you registered with, you will find out that there will be no issue. You will see your name, you will see all your scores. Alright? Right? Exactly. So there will be no issues at all if you always submit to the email address you registered with. But don't worry, if there are any issues, we'll see how we can help you solve it. I'll collate that to help you solve it as well. So that is for that. We'll be updating that, and as well. If there are any issues, just take the test and you will be able to get all the other details. So that is all for. I know this is why I didn't want to show us the certificate of the class. I know that everyone will be distracted trying to find their name, their attendance, and everything, right? So um right now, I'm just going to go over the rest of what we've learned. I'll be inviting my colleague Amina. She'll be taking this session. She'll just take you through all the other notebooks, class and activities, and all those things that we have done. I'm just asking you a few questions. There was one class that was not I attended the class, but it was on my own. I don't allow you. I don't get you, but not to worry. I'm sure that you'll be very fine. Okay. All right. So Amina, all right. So Amina will be taking the rest of the class and just reviewing what we have done, and then I'll be back towards the end of the class as well to close with us, take a group photograph, and where's oh, I hope you've been able to see my screen all along for people following online. Okay, great. So for that, everything is checking. Exactly, just hold on. So please let's check that and just don't worry, you will see some updates and reviews also on that one. Okay, so Amina, over to you.
Hello everyone. Please confirm if you can hear me online. Okay, thank you, Trust. Thank you, Paul. Okay, so let's start. So after the first class on Introduction to Artificial Intelligence, which my colleague just took, the next class you had was on the core concept of machine learning, which I'm going to walk you through. Again, it's a review, so feel free to ask any questions you have. But we'll go through together. Okay. I'm going to skip this part on what is machine learning. I think we just did that already. Okay, so we're going to talk about the basic concepts we need actually to build a machine learning model. And we all know that before, my colleague spoke about how data is everywhere. So how do we use this data to build artificial intelligence or machine learning systems? So already that gives us a pointer that the first important thing we need to build a machine learning model is data. And data is everywhere, as my colleague has shared. So what is that data? It's simply a representation of information, either an event, as we are right here, the pictures that are taken, the images, the audio, or a text image or a video. You have a question? Yes, all the resources will be uploaded on Google Classroom. Okay, so as I was saying, it's simply a representation of information. Now we know what data is, and we know that we need data to build a model. So what next? What's the next key buzzword, as I would say? The next key buzzword that we have in machine learning concept is train. We all hear train a model, build a model. What actually is that train? Is it the regular train for transportation, or what does it mean? So it's simply teaching that machine learning algorithm to actually identify the labels we want it to identify. And the labels could be anything. We'll get to that soon. So it's just teaching the algorithm to identify a pattern. And the pattern could be anything, as I said earlier. So it's similar to how we are also being trained for kids in school to learn something. We're trained to learn a pattern in a particular area or a field of specialization. It's the same thing that applies here. And what is the feature? The feature are those collection of data points that we have that gives us a relative information about the label or the pattern we're trying to find out. For example, say I'm trying to build a machine learning model that wants to differentiate between a male and a female. I will gather data points about what males and females look like and what are the key features. So those key features, I will have females have long hair, or longer hair than males. Females have certain body structure. Females look like this. They have this kind of eyebrow. They have this kind of nose. They speak in certain way. They have certain height. I will gather this information, and this information are my features. They are the data points. The label in this case would be male or female. So because that's what I want the machine learning model to identify. So again, let me walk back. The features are the observations or the relative data points we're trying to gather to predict a pattern or to design an algorithm that recognizes a certain pattern. And the pattern could be anything. So in a data set, we'll have features and we'll have the target. So the features will be all other data sets that are independent of the target, but they give you some certain type of information about the target. And the target is the label. So you hear people using them interchangeably, target or label. Any questions so far before I move on? Any questions? Okay, great, I'll move on. So now let's look at this in the machine learning term. So typically, machines do not understand text. Whether we have structured data or unstructured data, they do not understand text. We have to represent this in numbers because if you pass a text into a machine learning model, I'm sure you would have tried it already while experimenting. We'll get there. If you pass a text into a machine learning model or any computer algorithm, let's even leave machine learning out of it, it will not recognize it unless there is a kind of encoding behind the scene, a representation. That's the reason why you do encoding in the first place. Because if you pass just text to the machine learning model, it will not be able to recognize it. So you need to do encoding. That's one of the key reasons for encoding. Encoding is just you representing that text into numbers. So those numbers will be in space future vectors, and the features, as we've explained before, are the data points or the other observations you are trying to make sense out of in relation to a target. So the feature vector are those other representations of the data points that you've actually translated or encoded into numbers, and that's why they're called feature vectors, because they will be 2D in dimension. So that's why there is a vector. I'm sorry, 1D. That's why it's a vector, not a matrix. So the label, as I said before, is that particular pattern you want to predict. So over here we have um, a very interesting example. We want to predict different modes of transportation: bicycle, boats, cars, or plane. So how do we what here would be the labels? What here would be the labels of the algorithm? Can someone tell me? What would be the labels in this case? We want to predict patterns of means of transportations, and we have different representations already. We have cars, we have boats, we have bicycles, and we have planes. So what should be our target here? What should be our label? What? What? No. No, the labels are actually these things I mentioned. We want to tell which one is a bicycle, which one is a boat, which one is a car, and which one is a plane. So now we would have to gather the features that makes a plane a plane. What makes a plane a plane? What makes a bicycle a bicycle? What makes a car a car? And what makes a boat a boat? So you gather those data points and then represent them as vectors, which are the feature vectors. And the labels again will be your bicycle, your car, your boat, your plane. Because when you try to make sense out of the data points, you find that there are certain unique things about bicycles. Bicycles have just two wheels. What is the unique thing about boats? They don't have wheels. Can a bicycle walk on water? No, you need a boat for that. Can you fly a bicycle up in the air? Yes. No, you need a plane for that. So there will be certain key features, and these are the visual vectors. So let's take an example here. In school, normally we're taught certain things in class, which are the classwork, but we're always tested on the knowledge that we've tried to gain. So the teacher will always want to test if you've understood the concept that has been shared in class. And we cannot be building a machine learning model and not evaluate it if it actually understands what we're trying to show to it. And that's the reason why at all times we try to have train and tested. The train is we have the examples and we're sharing it with it. These are the answers, these are the questions, or you learn from it, just as we do in class where you are giving practice questions with answers. Then you have the real exam, which is the test. You remove the target and ask it to predict. Okay, let me see how well you are able to answer the questions that are posed. And that's the reason why we use evaluation matrix to also judge or um, evaluate the model on how well it's able to actually learn the pattern. If we're using accuracy, for example, and it has 30%, it means it didn't learn at all. It failed because the pass mark would have probably been 60% or 70%. So it means it failed. But if it's having 80% accuracy, even you feel, oh wow, I built an amazing algorithm. It's actually learning and predicting with 80% accuracy, which is very good. So moving on. So let's see, who can give me like an example of the different types of learning we have? Supervised, unsupervised, semi-supervised, and reinforcement learning. Let's see. Who can try? Okay. Yeah. Yes, yes. I like how simple you presented it. Yes, it's very similar. So yes, all what we've been doing in class so far is supervised learning. Even what you do in school is supervised learning. In fact, I think Okay, let me not go there. I'll get there. Part of life itself is supervised learning because we learn from experience. It's the same thing. So you are shown examples and you learn from that examples. That's supervised learning. But unsupervised, you only give it training data. You don't give it the answer. It's like I tell someone to walk in here and tell me who amongst these people, let all of us sit down, tell me who amongst these people are from the north, who among these people are from the south, who are from the west, without anybody saying anything. Just walk into the class and tell me. But the person starts saying, okay, these people that are dressed in hijabs are from the north, or these people that wear glasses are from the south, or something like that. Or the person could be wrong. We did not give the person the answer. We are not saying anything because the person would have guessed from our accent if we have one, or would have guessed from maybe how we pronounce words, or interacting and asking us questions like our favorite foods and all that. But we're not saying anything. We just said just the way Aura is working in now. Alright, please tell me, what are the different geopolitical zones of everyone sitting here? That's unsupervised because we did not tell alright, ask this person and ask the person to tell you his favorite food and from there guess the person's state of origin. So that's unsupervised. So unsupervised mainly works in clustering, customer segmentation, and when we're trying to do, it's very similar to what MTN does that a lot. You see that I'll be getting, all of us here will be using the same MTN, the same network, but we'll each be getting different types of ads and different types of promo offers. The reason is because MTN have observed certain behavior between how we buy data, how we interact with the services, what type of services we buy, what type, how much airtime we buy per month on an average, and etc. And they would have clustered us that okay, these people, if I try to sell this product to this particular group of people, they will buy it. But if I sell to these people, they will never buy it. For example, I cannot sell a promo to of 20,000 and tell the students to purchase it. Uh, well, me, I will not buy it. It's out of my budget. And I'm sure NTA would have noticed that for me, I'm purchasing 100 naira, so I'm even borrowing on top. So, so they will not want to sell that kind of promo to me, right? But when they see a businessman always buying 10,000 naira airtime, sending airtime out, purchasing large amounts of data, and all that, obviously they want to be sending that kind of promo to that person because they would have observed that that person can do it. That person is able to. I just need to pitch the idea in a certain way to the person, and the person will subscribe to that product. So that's unsupervised learning because we did not tell anything about us. NTN just looks at our features and predict, and they could be wrong sometimes. They are not always right. They could be wrong, but they are learning. They are learning from what they are seeing. So we're not showing them the answers. So that's unsupervised learning. And we also have something like semi-supervised learning. Not to complicate things, semi-supervised is more of combining supervised and unsupervised learning. An example is, let me see, it's like we give the algorithm a small example without showing it all the answers. Let's go back to that car, yeah, this example. So for semi-supervised, we would have maybe told it this is a boat and this is a car, but not tell it that that is a bicycle and this is a plane. We want it to on its own just guess what do you think these two things could be. So that's semi-supervised. In this case, we've combined supervised and unsupervised. We did not tell it some labels. We just fed it with some labels and want it to cluster for us. Maybe this type of means of transportation are land based, meaning they only work on land, and some work only on air, and some on water. So that is semi supervised. Are there any questions so far? Yes? Thank you, Bukola. Any questions so far before we move on? Okay, so moving on, the reinforcement learning. All of us who have been playing games, Super Mario, Bounce, if you played Bounce on Nokia phone a lot. Those what other games can I name? There are a lot of them out there that you've played, even Temple Run. They are all reinforcement learning examples, and you don't even know about it because it's like I throw an agent into a space, and I tell it I'll give it a criteria. If you touch this table, minus points. If you are able to walk from here to here without touching this table, just walk to the door, plus points. You don't tell it what is wrong, what is right. You just give it scoring plus or minus points if it fails and if it does not fail. It's similar to how a child learns to say a child is learning how to walk and the child is walking around here. If the child hits this table and fall and notice that it hurts him, the next time the child will not want to, he will find a way to navigate it and find a way to walk in a path that does not hurt him. That's reinforcement learning. And as I mentioned, it's similar to the games we've been playing, Super Mario, Bounce. If you fall into a pit or you fall into a hole, you start the game again. If you are able to cross over to the next brick or the next block, you move on and you level up. So that's reinforcement learning. It's just simply we have an action, we have an agent, we have an environment, and we want the agent to learn from that environment and take certain actions on its own. Now, what we do is that we will now judge the agent if the action it took is optimum or not by giving it scoring points. So that's simply all reinforcement learning is about. You have an example, a question. All right. Google. Oh, that's a very good question. Yeah, that captured it. I would not say it's a reinforcement learning. I would rather put it as a semi-supervised learning and not a reinforcement learning. The reason is because most times reinforcement learning works, they mainly work in an environment and a game. Now, for that capture, there's no environment. And yes, they're trying to test if you're a robot or not, but they're also learning. If you notice, the system gets improved every time. They're also learning from how humans actually input the answers. And I think there was a time also that I didn't get all the answers, but I was still think I'm not a robot. Yeah, I think I've tested that before, and I was still think I'm not just one failure, right? So that would not be reinforcement because then if it was reinforcement learning, you have an environment, you will not be told the answer. You have an environment and you just have to find a way to solve a problem. The problem is navigate through the environment, learn from the environment, and find the most optimum paths to solving that problem. As what reinforcement learning is about. Any other questions? Okay, so before I move on to the next topic, at the beginning of the class, I'm sure we would have been told the different types of supervised learning we have. Can someone share if they remember? And okay, I need the two subheadings. What are the different types of supervised learning we have? Not the types of algorithms we use. She actually got it, but I was expecting she would remove the regression. She got it, linear regression and logistic regression, yeah. But they both fall under different, even though they are bearing the name regression. Linear regression is for regression problems, and logistic regression is for classification problems. Okay, what's the key difference between regression and classification problems? Yeah, works with binary, discrete, 0, 1, 2, discrete. So can someone give me like an example of the both of them are numbers because at the end of the day the classification you still represent in numbers. So how do you know when you see two numbers. Let's say, for example, you have a data set and you were not shown bicycle, car, boat, plane. You were just shown 0, 1, 2, 3, and then in that data set you have 0.11, 0.12, 0.13. The first data set is class A and the second data set is class B. Of these two classes, A and B, which of them are regression and which of them is regression and which of them is classification? Yeah, that's correct. You're confused. Okay, the question was, we have two data sets, class A, and in class A, the target is presented as such 0, 1, 2, 3. In class B, the target is presented as 0.11, 0.12, 0.13. Yeah, so which of them is classification? Yes, exactly. Yes. Okay, yeah. So as you've all rightly said, with classification we're dealing with discrete values. In the target, by the way, that doesn't mean that in the future vectors, which means the other variables you are dealing with, the x variables, that doesn't mean that you will not have continuous variables there. You have continuous variables there, but the target itself is what you're interested in. That's what differentiates classification and regression problems. So the target in classification would be discrete, but the other variables, for example, if you have age, if you have income, maybe you want to predict insurance, if someone will get insurance or not. And you have age column, you have income, you have EMI, height, all those will be in continuous values. Except age though, age would be obviously it has to be a whole number. Somebody cannot be 21.5 years old. So it will be discrete, yes, but what I'm trying to point out is that you could have other continuous variables in the x variables, the other observations you're looking at, like the BMI. BMI could be 116.5, or you could have income continuous or landmass, population, all those could be in continuous presentation. But the Y is what differentiates the continuous, the regression and classification problem. So I hope that is fine. You have a question? Right. Which of the color is that? Colors. Colors. You mean colors as in red, blue? Why are they not discrete? I don't think they should be discrete. But then now that we think about it, it's just, you mean representing black as in the binary number 0000 hash, something like that. Yeah. Yeah, I think it can be in between. Yeah. Yeah. It can be in between. Like RGB is just standard. In between red and green, you can have other colors. So yeah, shades. Okay, so types of classification models. Of course, these are just very few of them. There are more than that. We have logistic regression, there's decision tree, random forest, etc. There are others. Let's see. Can someone mention the ones that we do not have here? Let's see if you've been able to do some studies on your own. Yeah. K-nearest neighbors, yes. Support vector, yes. Yes, now I have one tricky question. K-nearest neighbor, can we, okay, let me, K-nearest neighbor, can we strictly say is a classification algorithm? Yeah. Yeah. So there are some of those that I think the only two algorithms that I've found so far that are very that are just unique to the both problems are linear regression and logistic regression. You cannot use linear regression for classification problem because of how it models the data and how it and you cannot use logistic regression problem. But the others they like to make more friends on the so yeah. Okay, so before I go into this, how would you identify a linear and a non-linear data? Someone asked me this question. Now, someone asked me this question some weeks ago. How would you identify a linear and non-linear data? You can try. Yeah. All right. All right. The mic. Yeah. So.
Linear is like the meaning of linear is literally like a line, and yeah, I guess when your data, I think maybe I have the answer wrong.
No, you can
Um,
try. It's okay.
how do you know the difference between linear data and non-linear data? I guess linear data is two-dimensional, and non-linear data is more than two-dimensional.
Well, close, but I would rather say that for linear data, it's very simple as what we've been taught in maths. We have linear data. Remember when you try to plot line of best fits? For some of the data points you've been given, it's very difficult. It's like it's almost impossible to find the line of best fit because it could connect only one point or 2 points. You have to keep shopping around to find and the line is not always going from the axis. It can come from some other point. So for linear data, all we are trying to do is can we plot a line of best fit? Then by best fit, I mean not just any line, but the line that actually is able to separate the data point. As we can see, we have two data points here. One of them is blue and one of them is orange or yellow. How do we find that best line that separates these two data line of best? Now there are some data that are not separable. You can just see these two balls mixed around each other. Would you be able to create a line of best fit with that data? No, you have to do something like a polynomial or a curve or even a circle to be able to separate those points, like moving around in circle like a round so a roundy track or something. That data is not linearly separable and hence non-linear. So in that case, that's why data processing and EDA is very, very important. So when you are doing data processing and EDA and you try to visualize your data, you notice that when you do there's a very nice function, although people mostly often use scatter so plots, or you could use I always forget what pair plots on Seaborn. Pair plots on Seaborn. It actually shows you the line and shows you like yeah. So if you use something like that, you would definitely see it clearly. This data, it's not linearly separable. Like so, the best thing it also informs you of what type of algorithms to use. As the name implies, linear regression. It works with line of best fit. In fact, if you want to be able to see how the model is able to separate your data after applying linear regression, there is a default parameter on sklearn that says fit intercept equals true or false. You can actually plot and see and print out what it predicted and see if the model did well or not. That's one very good way of also evaluating your model, not just reading by the model score. So if, for example, after seeing the model score, you want to see does linear regression actually work for this data, you can use that sklearn function. Also, You can even just decide, because I can see that my data is not linearly separable. There's no need for me to waste my time and waste computer memory to try to use linear regression. Why don't I just go straight for the non-linear algorithms? So that's why, as I mentioned before, it's very important that you study your data, because, as they say, garbage in, garbage out. So if you pass in rubbish data, you do not even study your data, and you just start randomly applying models, you would not be getting the result that you are meant to be getting. So when you do proper ADA and proper data processing, you'll be able to tell already, this is the type of algorithm that will work for this data. This is the type of, although sometimes you're data scientists and you're also human, you do not have automatic decisions or automatic answers to every solution. That's why experimentation is very important. So they always say go with the no free lunch theory. Do not rely on one algorithm. Don't say this is the algorithm, this is it, that's the end. No. Try others and see. You could even try and see how well linear regression even works for a non-linear data. Just for you to, it gives you a bit of confidence also when you're trying to interpret and share your results with your peers or maybe the company. Why? Because the non-technical people might want to ask you, why didn't you use linear regression for this? Because all everybody knows is linear regression. So might not know this other bigger names, this bigger algorithms. So for you to, you say, okay, it's because this data is not a linear data, and here is why this is what I did and this is what I did. So it gives you a bit of confidence also when you know your data very well. So you studied it and you know it very well, and you are sure that the steps that you are taking afterwards, they will give you good results. So okay, let's move on. Understand how study but is it we want also a balanced data? Yeah, yes. Imbalance data is part of it mainly deals with your targets, because say that it mainly works with specific cases like cancer. You have a cancer data set and you want to predict who has cancer or not. Obviously everybody cannot have cancer. Like you have like an imbalance of those who have cancer and those who do not have cancer. Yes, sister. Yeah, so you would see that in that data set, there will be an imbalance of cancer and non-cancer. The cancer will be very small because it's unique. The non-cancer will be many because everybody cannot have cancer. Cancer is not like a plague that goes everywhere, right? So in that case, you have an imbalance data, and you see it in several other cases like fraud detection, all those unique, So yes, imbalanced data is part of what you study as your data, but it often comes only with the targets because that's mostly where you see it, imbalanced data. There are ways to deal with it, and there are ways to also like navigate it. In dealing with it, meaning you do not actually change the representation of the data. You are just trying to inform your model more because if your model sees more of non-cancer and cancer, when it eventually sees cancer, it will predict non-cancer, which is dangerous. So you actually want your model to learn both scenario very well so that it's able to differentiate both. So you kind of disguise. There are ways to kind of disguise the representations and balance it only for modeling and not in the actual data. Don't understand. I've not answered your question. Okay. Here comes with, okay, so let me see. I think I used to do it, but it mainly comes with when you've done all the data cleaning you want to do, data processing steps like filling in, taking care of wrong data entries, changing column names, checking for missing values, checking for trying to change dates to days, date column to maybe days, months, year, all those, although that's also causing in visual engineering. But EDA will now come with you've cleaned your data, you've removed all the debts from your data. Now you want to study your data. You want to know what the data is about. At what example? Like, yes, pandas profile, but yes, it helps a lot, but it's not always rely on it. But count plot is an easy, yes, it's a type because you're trying to compare because EDA can come in different forms. You can have yes, yeah, yeah. Also, that's the exact does that answer your question? Do you need more explanation? Does it answer your question? Do you need more explanation? You what? It's tricky. But see, you can also drop columns while doing EDA because you notice that those columns, maybe you would have done correlation plots or you would have done some analysis like bivariance analysis between one and one columns and you removed maybe a valuable information from that column, like the date column, for example. You already removed the day, the year, and the month from it. So you don't need the date again. It's redundant, so you drop it. But that process is not in the data preprocessing. It's just most often data preprocessing and EDA, to be honest, works together because you always tend to go back and forth. Yeah, so you do EDA, you see something, you go back and preprocess. You do EDA, you see something, you go back and preprocess. Does that help? Do we have any questions online? Any questions? Okay, so we've talked about what supervised learning is. Now let's take a look at how it works. So there are two types of supervised learning. I'm not going to go in depth into it. I've already explained one, which is the clustering algorithm. So I'm just going to go straight into what type of algorithm is applying in that area. So we have hierarchical clustering, K-means, and KNN again. I'm looking at if someone can ask why do we still have KNN showing face here again? Any guesses? People often say it's a lazy learner in the sense that it's like show me your neighbor and I'll tell you who you are. So it learns with those around. So it's also doing kind of like a clustering, it's bringing people that are close to it around. So that's why it's here too. But for KMs, it works with kind of like a mean metrics. It calculates like the mean. What's the average? Okay, say the three of us here. What's that one unique, let's say taking the three of our heights and getting the mean value of our height such that if someone comes in, we can get the person's height and say, okay, the person falls within these people because the person's height is close to the mean of these three people's height. That's how K-means works. Okay, so we're running out of time, so we're still in the first notebook. But really, I will implore you to go back to materials again once they are shared on Google Classroom. And don't forget, Google is your friend. So do a lot of Googling and reading, and let's move on. Any question online? Okay. We've spoken a bit about all of this, what you need to do with your data, with processing, different types of learning, and how you evaluate your data. So just a quick one, as we need to move fast, what other type of error analysis or evaluation metrics can we do for our machine learning models, aside the one we can see on the screen? Anyone? Those online, I'm also looking out for your answers. F1 squared. F1 squared is related to precision and recall. We can see there. What other types? Root mean squared error, yes. Mean absolute error, yeah, you're correct. MSC, yes, mean squared error. Yeah, awesome. What about underfitting? Yeah, underfitting is part of the error analysis because obviously you want to tell if you're that scenario where we have you've taught machine learning model something, but it's not even learning what you're teaching it very well. It's also failing on what you're trying to present to it. That's underfitting because it is not even learn. It's not learning what you're teaching it at all. So that's underfitting, and yes, it's part of the error analysis you do on your machine learning model as well. So here are some references. Again, the resources, all the resources to be shared on the Google Classroom. Do take a look, review, and we'll be there to answer all your questions. So we'll move on to the next area we covered during this class or this cohort, and that was our first implementation of a machine learning model, linear regression. Okay, I don't want to talk a lot here. I want someone to actually tell me all that we're doing here to see if you remember. The best cell, what are we trying to do there? We're trying to import our libraries. Why do we need these libraries? Yeah. Visualization, yeah. If you want to get a very quick insight of what is going on in your data. Yes. What about NumPy? No one said anything about NumPy. Yeah, you can use it to do all your mathematical. Yeah. No, no, no. No, no, no. You know that when you start doing some more concrete analysis on your data in terms of maths, those statistical functions, sometimes you might want to reshape your data. You need NumPy for that. Also, sometimes there are some plot functions you want to do. Those plot functions, those plot libraries were built using the idea of MATLAB. So they are mathematical functions and they don't work with text. Pandas work with text. NumPy does not. You have to represent it in arrays and so you have to transform it. So that's why I don't know if you went through that part. There's a place where you do something like values for your model, for your data point rather. You represent all your features in a form of like an array where it has all your feature vectors. Like one we saw here. The previous, yes. This is very similar to how this is how NumPy works. Arrays and like this is an array. So this is how NumPy works. NumPy wants this representation. So if you are trying to do something like that, you would need NumPy. And also NumPy is like the backend behind Pandas. Pandas was built, they work together. We can see that. So you do need NumPy. So sometimes some people ask why do I import NumPy when I don't even use it at all? So you don't know what's going on behind the scenes. Pandas is pulling in NumPy at some point when it's doing some analysis because it was built on it. So when you try to call some pandas for it, it's actually pulling in NumPy from the backend. That's how you import both of them. Okay, so let's skip through all of this. Can we use an histogram to represent a categorical variable?
Category histogram.
Why?
Yes.
Why not? What type of plots can we do for categorical variables? Batches, yes. So you also know, like, when you're trying to make a plot, you know what type of plot works for continuous variables and what type of plot works for categorical variables. Yeah, there are plots that works like that, like the counts. I think count plots, or there's a function in C1 to SNS dot cat plot. If I'm not mistaken, it works with both, but the continuous variable would be either in the mostly in the x axis, and then the categorical variable would be in the y axis. So it kind of disguises the categorical variable in giving it what they call dimensions. Or if you're trying to make a plot, what do you call that now? Say I'm taking it 0 to 1 or something. Can't remember. No, there's a name for it right now. I can't remember. Let's say I want you to make a plot of x and y, and I'm asking you to create your points in between. What do you call those points? Let's say 0.1, 0.2. Units, thank you very much. Yeah, so it kind of disguises the y in those units, and so when it makes the plot, the x, I think that's how box plot works. So that's also the reason why you see that this box plot is working for gender, which is a categorical variable, and tip, which is a, because it has kind of disguised gender as, and giving it those representation, because you cannot see take a look at this amount of tip now. Take a look at the amount of tip. So the amount of tip is in numerical variable, but the box plot itself ideally will work with numerical variables. But because there's a disguise behind the scene that kind of creates that representation of the amount of male and the amount of female we have in the data represented as such, that's why it works. Okay, so let's get through. Yeah, so why do we need to import for SQL and import matrix? Okay, there's a question. In my own understanding, F1 score um Chinwe, not exactly. F1 score is a type of evaluation matrix you use, just like accuracy. So you could use F1 score to evaluate on your train, and then your final evaluation will be on your test. How do we know the pattern to use? I think that has been answered, right, Paul? We just discussed it. What type of plots you use for different variables in your data set. Okay, I was asking why we need to import matrix for masculine. Yeah, because it's the container behind our all our evaluation matrix. We can also do from SQL import from SQL dot matrix import accuracy, like directly import the matrix we are referring to. But right now we're just calling all the matrix. We're saying SQL, show me all your evaluation matrix. I would select for myself and something. Also, but if you are sure on what type of evaluation matrix you want, I just directly call it from there from F1 score or accuracy or MSC, etc. But they are not matrix. It's like we have an organization and we have different departments in the organization. If we want to go for finance, we want to Okay. Okay, yeah, so it's like we have SQLN as a big building and it have different subunits where we get our matrix, where we get our train test split, where we get our model, where we get our confusion matrix, etc. Okay, so again, as we defined earlier, so in our data sets, we should be able to tell which one is which are the features, the X, the dependent, sorry, the independent variable, and the Y, which is the dependent variable. So because from the problem statement, we would have been able to guess that already. Like the Titanic data set you were working with earlier, in the problem statement, it says predict who will survive or not, right? So you already know that there's a column that will tell me that says survive or not survive. So already that tells you that that is your Y, and the rest of your columns are your X. So when you are trying to define your features and your label, you will know that when I get to that point, my Y would be that column that says survived or not, and the rest of them would be my features. So I hope you got that. Um, yeah, and let's see, I mentioned this earlier, but let's see someone can remind me why we need to do encoding. Why do we need to encode? Sorry. Yes, exactly. So, and oh, can you please before? Oh, please do my. Okay, and Paul also answered us, yeah, Zoom to convert objects to integer. Because we stated earlier that our models, their machines, they don't understand text. We're the only ones that understand text. Every single thing we're saying, our video, audio, they all can be presented in binary formats, which is what the computers understand. 01, 01, 01. So when we have text in our data, we will not be able to translate that to the model without encoding. Encoding doesn't mean you're changing the data, you're just representing it into numbers so that the model can understand. Okay, and I hope God remember how to call our models and do the predict function. Also, why do we predict only X test? Why just S test? Why not? Why don't I just fit on S train, Y test, and predict on Y train? There's a particular reason why do we just this is like a trend. Every single time I want to fit a model, I fit on X train, Y train. Why? Exactly. Thank you. That's that's the key word. So you need to keep a batch for your model. Your X train is what you want to train your model with. The batch of data you want to train your model with. Now you've hidden the test away from it, which is your Y test, your S test, and you want it to be saved, and then you compare that because you know you always compare your predictions to your Y test. Compare your Y test to your Y test. But you want to compare, is my model able to get my answers? Is he able to get all my answers? What is it predict? Let's compare. That's how exam works. The teacher has all the solutions and then it brings out your exam or test script and compares if all the answers you've solved are actually exactly what he or she had put down. Yeah, and we can visualize, sorry, we can read predictions into CSV files and save them for submission. So when you are doing your AI innovation hackathon, so I hope I'll see all of you on that one. That would be great. Ladies. Okay, so let's move on to the next notebook. So yeah, that was our first regression problem. Afterwards, we did. hands-on on classification. So I'm going to skip the whole introduction of the. We've done all that already. So we'll just go straight to yeah examples of classification. We'll just go straight to we already discussed how classification learning problems are being phrased at. But we also discussed that there are different types of classification, the binary and the multi-class. So the example we dealt with earlier on bicycle, cars, boats, what type of classification problem would that be? Multi-class. Thank you. It's multi-class because we have more than two labels. So for the binary, we would have something like cancer or not cancer, spam or not spam, churn or not churn. Thank you. Exactly. So the binary will always have more than two. And so sorry, the multi-class will always have more than two, and that's why it's called a multi-class. Yeah, as we can see in the visualization here, we have two data sets that are trying to be separated, two labels rather, class A and class B. Whereas for the multi-class, we have three labels, the circle, the triangle, and X. And we want our model to be able to identify each of them. And we've also gone through the types of classification algorithms we have. So yeah, we'll discuss this too, how to differentiate between regression and classification problems, and we also talked about the examples. Okay, yeah, pass off your percentage. Yeah, another key point of distinction between the two types of learning problems regression, it's the evaluation matrix. You cannot use MSC for classification based algorithm. You can't use MSC, you cannot use F1 score for regression based algorithm because those types of evaluation metrics work strictly for unique learning problems. MSC, MAE, RMSC, all for regression problems. F1 score, accuracy, area under the curve, all for classification problems. Okay, let's jump right into jump right into the implementation. That would be the next step. Okay, gone through all of this. Yeah, in this particular data set, we wanted to be able to predict if a client will purchase an insurance scheme or not. So that's why in the purchase column, which is our target, it's showing not purchase, purchase. And remember when I said that although you have your Y in distinct values showing you that this is the classification target. Other representations of the data might be in continuous values. For example, can we say estimated salary is continuous? Is this great? Continuous. Don't be deceived. It does not always be in point. It's continuous, it's not discrete. Yes, it varies. It's not like one. We're not saying 1, 2, 3. We're saying 19,000, 20,000, 21,000. So yeah, that's a tricky question. Sorry. Okay, so and we also yeah, we also explored how to use again our profile reports to view some of the characteristics of our data and read them. Let me scroll down here. Do we have any questions on some so far online? Any questions? Okay, I'll take that as a no and move on. Okay, here's the count plot we were discussing earlier. So in this case, we use it to visualize the counts of, okay, the person that asked me about imbalance data, what type of data would we call this? Imbalance. But imbalance to a degree. It's not high level imbalance. It's reasonable because this one is like almost at the middle of zero. So we can be comfortable to even try algorithms, start trying to do anything with the model again. Do you get it? So if for example the one was way below like 30%, that's also something you should study. When do I need to deal with imbalanced data? To what degree like do I have also it's with in reference to the problem statement as I mentioned, it's in reference to the problem statement. In this case, we don't want everybody to get insured. It's not everybody that can get insured. The insurance company will go bankrupt if they insure everybody. So they want only certain types of people. So it's okay to deal with the data like this because the other representation, the one, is at the middle level. So it means if I have 100 people, 50 people will get insured. That makes sense. Real life scenario. It makes sense, right? So okay. Yeah, so this is part of EDA. This all these are part of EDA. Comparing two columns. You have a question? Okay. Now for the oversampling, we just try to up the one so it's the same level with zero. So for the undersampling, you downsample zero. There's a method for it. No, no, no. You should. Yeah, yeah, and you could also, oh, it's just you, like when you're calling out the method, when you're calling out the method and you say dot oversample or dot undersample, you specify which of the variables you want to oversample or undersample. And when you're on it, it's also important to understand the concept behind oversampling, and you don't want to undersample one. One is already in low representation. Undersampling it is an error. So it's also important that you understand the concept behind why do I need to oversample and why do I need to undersample, and which of my variables do I oversample, which of my variables do I undersample, and how do I do that. So it's important you understand the concept behind oversampling and undersampling and why you need to do it. So in this case, you will undersample zero because it's in high representation. And if you want to oversample, you oversample one. Because it doesn't make sense for you to oversample zero again because it's already way up there. Okay, so let me check for questions on the chat. Questions here. Um, yeah. So we'll move on to model prediction again. Okay, in the first example we did, the first notebook we looked at for regression, we saw that we're applying linear regression. And in this case, we're applying logistic regression. And we all understand the reason for that. The first example was a regression-based problem, and this one is a classification-based problem. Okay, I want to ask a very interesting question here. Why do we need confusion matrix? Why do we need that very confusing matrix in the first place that always confuses people? I get why the name is confusion matrix. It really is a confusion matrix. Why do we need it in the first place? And what is it about? Similar, but I'm looking for a unique answer. Hit it. Yeah, we need it. It's an error analysis. That's true. I should have asked a question, but I already gave the answer. It's not an evaluation matrix, by the way. I should have asked that question, but I already gave the answer. It's not an evaluation matrix. It's an error analysis method. You are analyzing what your model is doing right or wrong. You're not evaluating. You're not getting a score and evaluating. For example, you cannot submit the score of confusion matrix on a leaderboard. if someone asks you what is the score of your model, you say, okay, I have a confusion matrix and I have 52 here, 0 here. You're not evaluating, you're doing an error analysis because you want to tell what is your model doing wrong and what is your model doing right. And that's why we have true positives, false positives, true negatives, and false negatives. Now, what's the difference between each of these? What is true positive? What is true negative? Okay, so what was the tricky question I wanted to ask? Yeah, why are we doing no one has answered the question. Why are we doing confusion? Why are we even bothering with this confusion matrix in the first place? Thank you. That's the reason. That's why I said it's an error analysis. So, for example, I was let's do this. You have a cancer data set and you want to predict who has. I like using the medical scenario because it's a very unique. In that case, if we're talking about a life and death thing, like a very critical and sensitive thing, you don't want to tell someone that has cancer that the person does not have cancer. It's more dangerous to tell someone that has cancer that he doesn't have cancer. The person goes about, imagine someone that has liver or lung cancer and the person does not know, and the person came for a test and your algorithm says you have no cancer, and the person continues smoking and drinking and living all sorts of lifestyle. The person ended up dying. You know what that means as a medical practitioner? Like, it hurts your career. You have to submit your license. Your license will be seized. And aside that, like, it's the optimum goal of a medical patient is to save life. That's what they swear. Like, that's when they are taking an oath. That's what they say. They want to save life. So they don't want to be telling someone that has a disease that the person does not have a disease. So imagine your model is doing very well and has 80% accuracy. Meanwhile, because accuracy doesn't deal with your negatives, the algorithm is actually predicting a lot of people that has cancer does not have cancer. It's having false negatives. So how do you like that's the reason why we need this confusion matrix. So if we are dealing with that kind of scenario, we want to see how many times our model said is correct and is correct. How many times did it say it's right and it's right? How many times did it say it's wrong and it was not wrong but it was correct? How many times that's false negative? It was positive, but it said it's negative, false negative. How many times did it say it was positive, but it was actually negative, false positive? So that's the reason why we need confusion matrix. Mm, yeah, so interpretation of the one that was done in class. The model said there are 52 true negatives, meaning 52% of the time our model said that the customer did not get insured and the customer truly did not get insured, true negative. 28% of the time the model said the customer gets insured and the customer indeed got insured, true positive. Okay, so what percent? Yeah, we just explained this, and this is just the formula of what I just explained. Do you recall how many times the model we're trying to how did I explain this precision? And it can be quite confusing, but for precision, we want to see how precise in terms of precision. We're actually dealing with I'm trying to teach a child. I'm teaching like what we're doing right now. I taught you something and then I gave you a test. And then I scored you based on how many times I have the total number of correct answers. And then I scored you based on how many times did you say it was correct and it was correct. I don't even care about if you fail something. You know, there was a time Jam was doing this negative marking something, like scoring you if you failed it, they'll reduce that from your score. But in this case, I'm not caring about if you failed it. I actually want to appraise you, so I'm judging you based on how many times did you say it was correct and it was actually correct. That's precision. How precise is the model? But for recall, That's where it lies in medical scenario. We don't care about how many times you got it right or unsaid to right. We actually care about the negatives, and that's why we call you pay attention to the false negatives and negatives. Okay. An F1 score is just combining the both of them to get a good balance of how the model is performing. Let's see that in bold. Okay, this is what we just dealt with. Just going to move on to class 6. The correlation plot, yeah. Support, support. Afterwards, point after the oh, I try not to talk about that because that would create a bit of confusion. So right now, I feel you should pay more attention to getting digesting the concept of what we call and what precision is. Once you get that, confusion matrix will never confuse you again because that's that's actually what you need to understand confusion matrix very well. For support, it's just adding extra to how these other um terms play. The actual occurrence of it just it deals mainly with imbalanced data. So yeah, so let's move on to yeah, so this was the Titanic data we dealt with. So is there any unique thing here that we need to discuss? In the meantime, do you have any questions? Okay. No, there's no uniqueness. So it's just still reversing back to what we've been talking about all this while, and how to deal with classification problems, and submitting how to get your F1 scores and submit it. So yeah, this was what you discussed yesterday with my colleague from me. How do you deploy your machine learning models? So all of this you're doing, you don't want to just sit down in one corner of your room building machine learning models and just storing it in your system, occupying your memory, and maybe you have a special folder for machine learning models and you keep calling them model one, model two, and they pile up for years and no one knows about the awesome stuff that you're doing. Why learn it in the first place? Why build it? You want to solve a problem. You want people to be able to use your solution to a problem. So you need to deploy it, and that's the reason why we took the class on deployment. So it's very important that as you are building the models, you have an idea of how you can be applying it to real life scenarios, and also getting it out there to the world. Because nothing is perfect again. So don't feel like, oh, the model is rubbish or nobody will use it. Oh, I need to make it so perfect before I send it out to the world. In that case, your model will go gray hair and it will never get done because it will never be perfect. You need people to test it. I mean, take a look at our, let me start from our computers. Ah, who was born in 1980? How was even 10 years ago? How did the computers look like? Were they as sleek as this? They were very heavy. If you carry a laptop, it looked like you have a hunchback or your back. It's like you loaded like 6 big books, engineering maths and all. And you but look at laptops today. You can even fold a laptop and I don't know what they call that and put it in your bag, and no one knows that you have a laptop. That's because
I'm sure, sorry to interrupt the amazing session that is ongoing. My apologies. Okay, so I just want to confirm. I've sent an update on the classroom, and a number of us have some issues with the attendance. And really, there is no issue with the attendance if you have used people online as well. There's no issue with the attendance if you have used your email as described correctly. All I just need you to do, all I just need you to do is kindly check it out. But tomorrow the whole thing will be updated. But I've tried to help. And if you follow those steps, I'll be able to help properly. That you have registered, you use your email, you can now change the email you use for your quiz. Right? Don't change your quiz answer. Change the email you use for your quiz. And because I will know you did a good answer actually. I won't want to be saying ask you. So let's do that. And yes, so that's just check classroom for the updates. And we have to close now for people online. Yes, apologies. We love you and we so much appreciate following. And the rest of the updates will be sent to you. I love you guys. But we have to close the online session. And if you still want to stay, and then I still available for about 30 minutes. So by 2:30, she won't be available again. Right? She's a very busy machine learning engineer. Very busy building products for 2 billion people. It's a lot of money. I mean, I'm serious. I'm not kidding. Alright. Anyway, so that would be all for today. And this program not ended totally because your badges will be sent to you. The entire deadline, the link is April 9th for all the quizzes. So by April 9th, you should complete all your quiz. No, is it April 8th or April 9th? 8th. Okay, so by April 8th, please complete. By then, all the quizzes will close, everything will close, and the next week you'll be getting your badges. So please make sure you do that. So thank you. Yeah, let me quickly check online.
Yeah, someone read.
Just what we scroll through. Yes, I'm still doing guys, you can still take all the quiz to the end of the session. No, you can't take all the quiz. No, you can't take quiz before that. Not taking the quiz. Sir, sir, sir. You need to review your quiz scores. Okay. Okay. Review his quiz scores. Alright, so now we are. Accepted iPhone score. Okay, so if you accepted an iPhone score today, it doesn't count. Okay? The first one you submitted is what's in the count. But thank you for submitting another iPhone score. Really amazing, great work. Okay? Yes. But like I said, all the quiz and all the attendance, just make sure when you're filling the test, please. I can literally kneel down to beg. Make sure you use your email address that you registered with, and then you actually registered and it is properly spelled out, and there will be no issue, I assure you. Okay? Awesome. Cool. Yes, the invitation you get it. When you use the attendance report, please check the classroom. You send your emails later, but it's now on the classroom. Ready? How many of you have been onboarded to the DSM mentorship platform if you are here? Yeah, the top 100 participants have already been put on the. But we're not done, right? Yes, but as at when the organization was doing that, the top people was an email, you saw there's one platform, right? DSM mentorship something, you have seen some people on the platform. Yes. How does the engagement? No, I think it's still you do. Yes, there's an onboarding message on the platform. But there was somebody will reach out to you in the coming days. But there was as long as you're on the platform, you're good. Okay, so it's like imagine Facebook, right? Was structured for mentorship. You have one-on-one meetings, everybody's trackable, you can meet with any mentor in unity where you can have video calls, you can join. It's an all-in-one platform on its own. Yes. So we at some point when we grow, we're gonna have an app for that. And why not just enjoy? Yes. It's from quiz, from the attendance. Yeah, that's why you have to submit them. Exactly.